Hello and welcome to our panel on maximizing efficiency in the data center. This exciting panel has a couple of experts in the space, and I'd like them to introduce themselves. First and foremost, I'm Kevin Imboden, Head of Research at Cushman & Wakefield in the data center space. And Professor Lee, if we could start with you, and then Mr. Murphy, if you could introduce yourself as well.
Thank you, Kevin. I'm actually the Poh Seng Lee. I'm actually the Deputy Executive Director with our Energy Studies Institute here at the National University of Singapore. So I've been working on liquid cooling for the past 20 years. So I'm very passionate about improving the efficiency of cooling for data center, as well as to lower the carbon footprint.
Excellent. Mr. Murphy.
Okay, thanks, Kevin. Arnold Murphy, I'm President CEO of Strategic Clean Technology, Inc. in Canada. We've been started the company about 12 years ago, focusing on optimizing cooling in data centers, which of course is very key from an energy efficiency point of view. We are the boots on the ground. We look at what's coming in the marketplace, but we implement. That's our primary strategy, implement to help customers reduce energy consumption. So we've worked in large colos, we've worked in large telecom sites, enterprise sites, just about any size of organization overall. Overall, I like to brag about the fact that our overall energy savings is on cooling side has typically been 36%. That's average. We've hit some cases where we've been as high as 43%, 46%, but pretty consistently 36% across cooling efficiency. We also do, in order to help us in some cases in larger data centers, we also do computational fluid dynamics airflow modeling, which is great because one of the issues, as we'll probably discuss today, is the fact that you can't see air. You don't know where it is, you don't know where it's going. You think it's going to do what you want it to do, but a lot of cases it doesn't do what you want it to do. It's going somewhere else as such. So airflow dynamics is a great way of showing that. Our team of engineers, we've got mechanical engineers, project managers, and HVAC specialists. I'm located in Ottawa. They're all located in Toronto. So, and we do work all across Canada.
Understood. Thank you. And those are some impressive numbers. And just for everyone in the audience to know, this was a fun exchange trying to get people from all over the world together for this panel. So there's a lot of brain power and a lot of energy expended here. Now, speaking of energy expended, our first question, and maybe Arnold, we could start with you. How does airflow management drive efficiency in the data center environment for those who aren't familiar with it, with how important airflow is?
Mm-hmm. Well, as I say, our focus is on cooling. There's lots of experts out there on the IT side. There's been a lot of work done on the IT side, improving efficiency of servers, etc. It's been, quite frankly, it's been incredible to see how much server efficiency has increased. The basic physics of it, though, is the fact that for every kilowatt of energy that's going into a server, you're generating 1 kilowatt of heat. And that has to be dealt with in the data center. In today's world, air is the primary medium that is used to cool. So you have to make sure you've got enough proper temperature airflow going over the server in order to cool those components properly. So when we look at a site, we take a holistic view from a data center point of view, what's going on within that entire data center to see what's happening to the airflow in there. And of course, I think we hear it a lot of times, people say, well, just increase the set points on your cooling units because that will increase the temperature and therefore increase the efficiency. But it's not as easy as that. Definitely increasing set points will increase cooling efficiency because your cooling systems have to work less, but you've got to do a lot of other work. And when we work in a data center, the very first thing we do when we walk in is look at airflow management. How can we improve that, and how can we optimize airflow management in there? So people talk about cooling capacity. We look at cooling capacity of systems, but we've seen many sites where you've got 2 times, 3 times the amount of cooling capacity in a site, but you still don't have N+1 cooling, which means if cooling unit fails, you're going to be in trouble. And that's because of the way the cooling units are laid out and because of the poor airflow within site. So improving airflow efficiency can, number one, reduce your OPEX costs quite considerably. Number two, it actually means too, if you do a good job of it, you can increase the IT load that you have in your site as well, because you've increased the efficiency, which means you're deferring CapEx, and it means also you're deferring CapEx for another cooling system or another couple of cooling systems that you would typically put into a site because you're thinking, I've got hotspots in my site as such. So there's all kinds of implications of improving airflow efficiency, and it's to me, it's the first thing that you should be doing in a site. And that's why if you look at our site, look at it in our papers, you'll see a little icon in the bottom that says airflow rules, because it is airflow rules in a data center. That's the most important thing that you can do in a site, and one of the biggest things that you can do to improve energy efficiency in a site.
Gotcha. And maybe to make this more tangible to the audience, is there perhaps a real world example we could use to start off with?
Yeah, well, when we go into a site, we have a total program called the cooling optimization program. But as I say, airflow management is the first thing. So, for example, go into a site and look and see, are they using blanking panels in their racks? Are there spaces between the racks, which means potentially the warm exhaust air is coming back around to the front of the racks, causing the inlet temperatures to increase in there, which in a lot of cases people say, well, I've got a hot spot in my data center. Well, let's have a look and see. Well, no, you don't. You do have a hot spot, but it's not because you don't have enough cooling. It's the fact that you've got poor airflow management. You're allowing that warm exhaust air to come into the site. Another case, so we always start with blanking panels, make sure they're in place, make sure there's no space in between the racks. We look at adding containment if that's feasible. In a lot of sites, it is quite feasible to add aisle containment or airflow containment, either cold aisle or hot aisle. So typically, I say in the work that we do, if you look at doing all of those measures from an airflow point of view, improving airflow management, and in a lot of cases too, we go what we call a step further. We go to airflow optimization, and what that means is how much airflow do I need coming to my racks to properly cool them, and how much am I actually providing? And our objective is to match that up as closely as we can, 1-to-1. So back to my earlier statement about producing a kilowatt of heat. For every kilowatt of heat that you're producing, you need the guidelines range between 120 and 150 cubic feet per minute. We typically use 150 cubic feet per minute. So if you look at your cooling units, your air handlers, your crack units, there's specifications on all those as to how much airflow they're providing. Hopefully they're reasonably close in the real world to what the spec sheets say. And we also do airflow measurements on the perforated tiles if it's a raised floor to understand how much air is actually coming up through the perforated tiles. And again, we've seen cases where we go into a quite well-run data center and look at the spec sheets on the cooling units and compare that to what our measurements are in the perforated tiles, and that's about 90%. We've gone into other data centers where we've seen that number being in the 30s as such. So that means for every cubic foot of air that you're putting out of your cooling system, 70% of it is going somewhere else rather than coming up through the perforated tiles. So you've got to look at the integrity of the floor. You got to look at the holes under the racks as well too, and make sure those are filled as well. So just by blowing more air into the data center is not going to achieve your objective of cooling the equipment properly. So as I say, when we by improving the cooling, by improving the airflow to the racks at the right temperature, you can then possibly push up your set points. And if you push up your set points by looking at let's use a crack unit as an example, you can increase the cooling capacity of that crack unit by 25%. So again, means I've got more cooling capacity. I can add more IT load to the site. I don't have to spend CapEx for an additional cooling unit as such. So there's a whole array of benefits that are achieved, and it's all driven by improving airflow management in your site.
Hmm. I don't think a lot of us are considering that. I think there's so many levels to this, and so when you hear that, and this is why I wanted you to go into that kind of detail, because there's so much that goes into it, and this is such a long study here. What are your thoughts, Professor Lee, on airflow management?
I think Mr. Murphy has actually given an excellent overview of the importance of data center airflow management. I'd just like to add that he mentioned, for example, the raising set point, improving, for example, the COP of the chiller system. I think on top of that, the holistic assessment will be the necessary. Because obviously, as you raise the set point, it's very clear that the cooling system will be more efficient, right? Because basically your evaporator temperature will be higher. But then there's also a potential power penalty for the IT equipment, right? Because now you're basically getting your junction temperature of your processor chips to be at a higher level. So that can actually potentially increase the power consumed by your server hardware. So I think my take is actually it has to be a holistic assessment, right? So beyond just looking at the cooling system power consumption, so you also have to factor the potential power penalty for your IT equipment. The other is obviously the so-called the IT equipment the reliability as you operate them at higher temperature, whether or not these are hardened so that they can still reliably operate at elevated temperature for extended period of time, because we know that obviously data center is expected to be operating 24/7, 365 days a year. So I think there are a couple of other associated issues that needs to be collectively addressed, well beyond just looking at the power consumption by the cooling system. I think the other thing is actually certainly, I think, to extract the most optimal performance out from the cooling system. I think obviously there can be the use of, for example, variable frequency drives for example, for your fans or for your pumps. So I think this will actually serve to further squeeze additional savings out from the cooling system. But I'd like to also mention that increasingly there's a lot of use of smart control, for example, through AI, machine learning. And I think with such systems, then there's actually a possibility to really look into the coupling of IT power and cooling, which I briefly alluded to just now, so that it can actually really holistically sort of assess what is the so-called the effects of making various the changes to the settings of your cooling systems, so that a balanced decision can be adopted.
Gotcha. So we have to remember that there's hardware efficiency and there's software efficiency. We need to optimize both in these cases.
And totally agree. I mean, it is, and that's the thing. I totally agree. It's a holistic approach that you have to look at the site to see. There's been some great advancements on the server side, and if you go back, I remember 2010, 2011, 2012, some of the projections that were there for data center energy consumption. At that point in time, people were saying, well, it's 2% of the global energy consumption, and we're projecting it's going to be up into the 15, 20%. Well, now I'm seeing numbers that are saying it's actually about 1%. It has not gone up that major curve that they were projecting, and a lot of it was due to server technology, the improvements in server technology, as well as virtualization and aspects like that as well. So it's, I mean, I read a number of reports, and people are saying data center energy efficiency has actually made some massive strides and improvements, which people were not expecting, I don't think, and I expect there's a number of reasons why that was driven that way, but it's definitely improving. Yeah, still lots of room for improvement, but definitely improving.
No, and I think that's fantastic, because what we're looking at on the data center construction side, I mean, we're looking at least 3 gigawatts globally under construction right now in terms of data centers. And so that's we have to do something to decrease the carbon footprint there.
Yeah.
I guess a question is, we started to touch on this with the AI, but what are some of the more recent advances in this type of cooling technology to drive these greater efficiencies? or there's some new technologies out there that we need to discuss? Because I think I've seen a lot of advertising, but I'm not sure what's actually working.
Yeah. Well, I always like to maybe take a slightly different view on that, because you've got a difference between legacy sites and new builds. And to go in and make a new build very energy efficient, I'll say it's pretty easy to do that. You put in the newest technology, the newest cooling system, newest servers, you name it, type of thing. It's great to do. As I said earlier, our focus is on the legacy side, and there's a number of challenges of trying to put new technology into a legacy site. First of all, I like to categorize the legacy sites in a number of different categories. Number one is you've got companies such as colo sites, large colo sites. And of course you've got the Googles, the Facebooks, the Amazons, etc. They make their money to a large extent out of how they operate their data center. They have to operate their data centers very efficiently, and colos are a great example. That's where they make their money, is how efficiently do I run my data center. Then you get into large enterprise organizations, and certainly across North America, you look at the financial institutions, the insurance companies, this type of thing. Some of them have fairly large data centers, not a lot of them, but fairly large data centers. But in a lot of cases, they outsource the management of those data centers to a third party. And the question then of what's the interest of the third party to make those sites more energy efficient? And in a lot of cases, and I know when we started this company a number of years ago, talked to a lot of CFOs and talking about energy efficiency and how we could make improvements in it and stuff like this. And I always remember the remark from a number of CFOs being, we don't even have a line item in our budget for electricity. So am I going to pay you're telling me I can save data center cooling 30, 40%? Am I really going to pay a whole lot of attention to that? And I think that tends to be the view of a lot of large enterprise organizations, because people are obviously a big cost, and other things are a big cost. From an enterprise, especially when you get into the financial and insurance sector, what's more important, energy efficiency or uptime? And when you look at the fact that they can lose millions of dollars a minute if they have downtime on their data centers, are they really going to pay a whole lot of attention to energy efficiency on that side? And then the other category is what I call the ones that have data centers because they have to have data centers. They really don't want to have a data center, but they have to have it to run their e-commerce sites, to run their manufacturing facilities, and this type of thing. So where I'm leading to that is I think there's a lot of great technology out there right now that just needs to be deployed a lot more in the legacy data centers as such. I mean, going back, simple examples of blanking panels and airflow or air management and aisle containment and this type of thing. Like, we see how many data centers out there that have not taken those very preliminary steps to improve the energy efficiency, not just on the cooling side, but overall within their data centers. The other side is the fact that they've got cooling units, older cooling units. They don't want to upgrade those cooling units. They don't want to go to newer models because of the CapEx expense. So my point being that, yes, there's a lot of new technology that's out there. We're trying to take advantage of as much as possible, but vast majority of the customers that we deal with are on the legacy site. And trying to move them to the point of saying you should be implementing this technology, not even necessarily new technology, but again, you've got to, in most cases, you've got a payback window that you have to fall within, either a 3-year payback window, or if you're really lucky, a 5-year payback window. And so you have to prove to them that the energy efficient alternatives that you're putting in place meet that time frame. And if not, then it's dead in the water. It doesn't go anywhere as such. So I totally agree. I think there's some great new technology coming out there, but I think there's a lot more from an overall data center energy point of view that we could be doing in the legacy sites, and somehow or other incentivizing those organizations to do more, to take what's on the shelf already for technology and put it in place and improve the energy efficiency. we've developed, I'll put a little plug in here, we've developed in conjunction with another company, a technology referred to as floating head technology. And that's focusing at DX units that are 5 years and older. And you look at it, the energy savings that we can generate with that is typically 35%, if not 40% or more on individual crack units in a data center. And here in Canada, I mean, some of your large colos are running chilled water systems, but we see a lot of enterprise, a lot of colo sites as well that are running DX crack units, which are 5 years and older as such. So the business case on this technology is a 1.5 year payback on it. We've done 250 or so units at this point in time, been great success. But again, companies are just, existing companies or with existing data centers are just hesitant, maybe don't understand that this is a great technology that they could be deploying within their site. And they're extending the life of their cooling units, again, deferring capital and improving cooling efficiency very dramatically with that. So that's my little spiel on new technology, where it's going. As I say, I think there's a lot of good stuff out there, but there's a lot that still needs to be implemented within organizations.
So my take is actually very similar. So I think there are a lot of wonderful technologies out there. So it's really to bring together the various pieces, so as to come up with an integrated solution that makes sense. So maybe to give an example, so I've been working on liquid cooling for the past 20 years, and obviously when you talk about liquid cooling, one of the common comments is nothing new, right? So that had been demonstrated probably like 20, 30, 40 years ago, right? But I think what we are trying to do, right, is really to make liquid cooling easy to use. Because the traditional implementation of liquid cooling actually involves the laying of piping right, across the data hall, going from your coolant distribution unit into the individual racks. So as you mentioned, it can be quite a massive piece of work, right? So if you have 500 racks, 1,000 racks, the kind of a infra changes as well as the CapEx expenses that will be actually required, and not to forget that you need to bring in actually new equipment like the coolant distribution unit. So the one of solution that we are actually currently the co-developing and demonstrating at a international co-location, the DC site, is actually basically integrating liquid cooling with the IT hardware. So instead of the traditional decoupling of IT from facilities, we are basically integrating them into a fully contained rack. So instead of selling just server hardware, you're actually selling a fully integrated liquid cool racks. Right, so when the customer purchase such a solution, right, so you can pretty much just send this integrated pot to the site, and you can simply just hook on the power and it's good to go. So there's no need for you to even, for example, lay any piping. There's no need for you to even bring in new equipment like the coolant distribution unit. So I think it's really about the integration of existing technology and sort of facilitating the use, as well as probably the maintenance of such solutions. So the other, I think, is actually also along the same line. So, for example, whether or not we can look into a circular, what I call circular cooling and heating. Right? For example, if you were to co-locate your data center with a source of free cool energy, right? Here in Singapore, we actually generate most of power using LNG or natural gas, right? So when the LNG is brought into the terminal, so it's actually in the liquefied form, right? So, but before you can actually use it, right, for power generation, you basically need to gasify it. And in the process, actually, it releases a lot of free cool energy. So currently, what is being done is we are piping in seawater, using it to heat up, right, in certain sense, the LNG, converting into gaseous form. And you're actually then discharging this lower temperature seawater back in the sea, right? So you're actually wasting the very precious cold energy resource. So one project that we're currently exploring is actually whether or not we can co-locate, for example, data center with LNG terminal, so that it can actually recover this free cool energy and actually using it for cooling data center, right? Thereby obviously improving the PUE as well as the overall energy consumption of the data center. So I think it's really about bringing the various available technology together in an integrated fashion and extracting the best possible energy savings as well as the carbon footprint reduction. Yeah, so I think that's really the way forward.
Well, and I think that's good to know, right? Because I think a lot of times there's a tendency to always look to what's newest, what's best, but really it's just using what's already out there and integrating it intelligently.
To a large extent, I would agree. I mean, there is new technology coming out there. I mean, of course, living in Canada, we always say, well, why haven't we got more data centers in Canada? Because of the climate. Free air cooling, you could use a lot of free air cooling. But again, it's maybe inappropriately, I use the term, it's a culture within the data center world. It's a change. I mean, you talk about immersion cooling. I mean, to me, that makes so much sense. But you're telling me you're going to take my servers and put my servers in a liquid bath? Like, are they really going to continue to operate like that? And so, I mean, you hear a lot of pushback on significant advances like that. But I agree with Professor Lee. I mean, here in Canada, it's a showcase that one of the large telecom companies developed, the TELUS Garden in Vancouver. And it's a 1 million square foot retail office facility, commercial space adjacent to a large data center. And so they're taking the heat from the data center and using that to heat the TELUS Gardens facility, which they say is 1 million square feet. Now, I think they actually did it as a retrofit to an existing data center, but first question is, are you making any money on that? No, probably not. I would say absolutely not, but it is a showcase as what can be done. We've talked to a number of companies about using excess data or excess heat out of data centers to do it, but air is not a good medium. And by the time you factor in all the other heat exchangers, heat pumps, this type of thing that you need to do, it really doesn't make a lot of sense, at least at this point in time. Maybe things will improve. Here, discussions about using fuel cell technology for energy generation to make it more efficient for use in data centers. I see some large colo companies are putting solar panels on their data centers to offset the cost of that. Of course, now I'm not sure how prevalent it is elsewhere, but certainly in North America, the use of RECs, renewable energy certificates, as such as part of the way of offsetting the I guess I'd say the appearance of energy costs as such within data centers. But so there's lots going on, but I think there's a lot out there that we could still be deploying within existing centers that would make them much more energy efficient. But it's just that it's the investment cost to get companies to do it. Here in Ontario, I mean, we're paying larger data centers are probably paying 10 cents a kilowatt hour. The normal consumer, the regular residential consumer, is paying, I think, pretty much loaded is about 14 cents a kilowatt hour. So it's fairly high cost. But even at those numbers, sometimes it's difficult to put a business case together to say that this is justifiable strictly from an energy point of view. So one of the things that we've been looking at for the last few months is how do we monetize the deferral of capital? We can go into a data center and see they've got, let's use an example of crack units. They've got 8 crack units in there, and they're saying, well, we think we need to buy a new one. By the time we're done work in there, they're down to operating with 4 crack units, maybe 5 crack units. So they don't need to buy that additional crack unit. So that deferral of capital, how do you monetize that and put it into a payback scenario? We're looking at ways of doing that. How do you monetize the fact that now I've improved your energy efficiency, the airflow efficiency and airflow effectiveness in your data center? Now you can load up your racks. Instead of having your racks at 6-7 kilowatts, now you can load them up to 10 kilowatts, which means you don't have to expand the footprint of that data center. how do you monetize that and put that back into a value that the customer can say, hey, not only I'm saving this much energy, I'm deferring this capital cost, which is equivalent to this, because I don't have to buy another cooling unit and I don't have to do an expansion on my data center. When you factor all those things in, it's a good picture. But how do you monetize that? That's what we're looking at trying to do.
I'll even throw one idea in there, because monetization often comes at the exit of the asset. And so on the real estate side, when we're looking at things, we're saying, oh, okay, when were the last time some of these units have been upgraded? And is the tenant going to stay in the data center, especially for these enterprise data centers, over the long haul? Because if they are, and the building has been kept up very well and all the latest cooling has been employed, well, the investor is going to pay top dollar for that, to the tune of maybe an extra 40-50% on the acquisition price. And so we try to remind folks all the time, hey, when were the last upgrades? Has the gens been kicking in a lot? And if the gens have been kicking in a lot, investors aren't stupid. They're going to look at it. They're going to ask why. And there are any number of extra things that come outside of efficiency, but are paid back when you end up selling the building. And so I think that's a little part at the end that a lot of folks aren't focused on too.
No. Well, especially in colo sites. I mean,
sure.
If you're the design or I don't even say design, the layout of your data center is such that you can only accommodate 3 kilowatts per rack for a customer, and we can go in there and improve to the point where you're carrying 6, 7, 8, 9, 10 kilowatts per rack for in a site. How much more revenue can you generate in that site? Because now I can accommodate a lot more customers in that site as well. But how do you, I mean, there's ways of doing it, but we just haven't spent the time to really try to put a dollar value to it. But when we went and do our work, one example we come out of, we call it released. Some people call it stranded IT capacity. We call it that. We also call released IT capacity, released cooling efficiency. A lot of cases, clients don't know how much cooling capacity do I really have in my site. They know from a spec sheet point of view what they have, but given the way your data center is operating, how much do you actually have that you can use in there? And we've created some metrics that we use of the amount of power per kilowatt of cooling required, how many kilowatts of cooling do you need for IT per kilowatt of IT load, and we use those metrics, and we've seen cases where we've increased the IT load, or we have given the customer the potential to add another 128% IT load in that site than what they had, and they thought they were running out of capacity for IT load. Well, no, you've got lots of cooling capacity here to accommodate another 100% of IT load, but you have to do the efficiency measures. You have to improve the airflow. You've got to improve the cooling efficiency and cooling effectiveness in order to make that work. So, but the old adage, you can't manage what you don't measure, and that's been a lot of cases where there is. How do you measure cooling efficiency? How do you measure cooling effectiveness? Well, we've developed some metrics that seem to work. Now, could you actually add 100% or 128% more IT load to that data center? Probably not, because it never quite goes as you plan, but certainly you could add another 70 or 80% of IT load to that data center and be quite safe with it. So it's just getting that information in front of clients so they understand what they can do with their sites and how much more they can do with their sites, I guess is what I'm saying, without having to spend a big amount of capital to achieve that.
Sure, absolutely. And I think you're about to hit on a point that it was another question I had, and I was thinking, Professor Lee, I know you've done a lot of discussion about this in the past. Has the way we view or calculate PUE changed over the last few years? And I'd love to hear your thoughts on that, Professor Lee, because I know we've talked about that previously.
Yeah. So I think the conventional definition of PUE still stands, right? So it's basically like IT plus facilities or over IT. But I think we have to recognize that this is essentially a ratio that describes how efficiently a data center uses energy relatively. So I want to focus on this relatively, right? So basically how much energy is actually used by the computing equipment relative to cooling and other overhead. So I think this ratio does not fully reflect, for example, the coupling between power and cooling, which I spoke about that just now. So to just give you examples, I think last year we actually completed a project whereby we actually demonstrated the rack of liquid cooled server hardware, right? And interestingly, by operating very high performance liquid cooling, so we have demonstrated you are able to actually reduce the server power consumption by as much as 40 to 50%. But then if you actually make use of the convention definition of PUE, imagine, right? So if your IT actually reduces by 50%, both in your numerator and denominator, in fact, your PUE will increase. So if we go with the conventional thinking, right, this is in fact less efficient. No, it's true, it's less efficient relatively. But if you look at the total power consumption, right, for the whole data center, in my case, the entire rack, is actually highly desirable because the total power consumption actually reduces, right? But then making use of the conventional PUE definition is not able to fully capture the effect of actually lowering the total power consumption. So that's why I thought actually PUE is certainly useful, right? But at the same time, it shouldn't be the singular indicator. It should be part of a bigger matrix, right? So that we can holistically assess efficiency, total power consumption, CO2 emission. Yeah, so I think there's probably a need to sort of relook or figure out, so what should be this greater matrix, right, of which PUE will be one of the indicators. Yeah, so as to allow us to holistically assess for example, the contribution by the operating or even designing of a more efficient cooling system.
Gotcha. I mean, that makes sense, right? If we're doing things so much more differently and doing a holistic assessment of everything in the data center, then one number isn't going to reflect that, right?
Yeah.
That makes sense.
Yeah, I mean, PUE has been good from the point of view, it's actually made people realize what's going on in the data center, but I totally agree with Professor Lee that it is certainly not the best metric out there that could be used, but at least it gave people a starting point to see what's going on. We've been working with the Canadian Standards Association here in Canada on a new concept. It's not published yet as such, but it's referred to as the benchmark energy factor for data centers. And the objective of that is to take into account both the IT side, the cooling side, and the what are called the auxiliary side, or the other side, the lights and all that good stuff type of thing, power distribution losses, etc. And it'll be published hopefully published as a standard in September so timeframe, maybe earlier this year. But the intent of it is to take into account the fact that if you are virtualizing, that's a benefit, but also the amount of work that's being done by servers. So essentially what it looks at is what's referred to as an ideal level of energy, and it's basically saying that's, in a perfect world, that's where you would be able to operate, but nobody will ever get to that perfect world as such. So where are you today relative to the amount of work your servers are doing, the types of cooling systems you're using, and your things like your lighting systems, your power distribution losses, etc. And then what could you do to improve that, and how close would that get you to that ideal world at one? So they're doing some testing with it now. As I say, it's been a work in progress for the last 3 or 4 years. I don't want to say it's another method of calculating really where you are in the data center, but I think it does take a more holistic view than PUE, because I mean, you go in and do a massive amount of virtualization in servers in a data center, and you've done wonderful. You've reduced energy, but your PUE's gotten a whole lot worse because if you haven't done anything with cooling or with any other structures in there. So people look at that and say, well, that was pretty stupid. Why'd you do all of that? You made my PUE worse. Well, I did the right thing, Just the calculation not in my favor.
That makes sense. Well, that's exciting. I mean, that's something to look forward to in September and find out what comes out and how we can utilize it.
Yeah, we're planning on doing a webinar probably in September timeframe on that in conjunction with CSA to expose that to people to see what their views are on it. But I think it's a pretty good system from what I've seen. Yeah, pretty good metric.
Fantastic. No, that's exciting. It's very exciting. So I guess one last question, and this is just general thought here. I mean, we've touched on how a lot of this is implementation rather than any new invention, but I mean, where do we go from here to drive further efficiency? Just what does the future look like? What else can we do? I mean, we start with implementation of what we already have, and then where do we go?
Mm-hmm. Yeah. I'll reemphasize that using what we have already. I mean, I hear quite often more training required of people in data centers, training of people that are operating data centers to understand what can be done and how to do it. I mean, the right sizing of not only on the cooling side, but on the power side as well too. Seen stats a number of years ago where 80% of all data centers never achieve 60% of their design build capacity. So that means that there's a lot of wasted, I'll call it infrastructure out there. I mean, how many companies when they're doing a new build go in and say, well, I'm 10 years from now, that's always the question that's asked, where are you going to be 10 years from now? Well, 10 years from now, I'm going to be running a 2 megawatt data center. And so as a result, all the infrastructure, all the cooling, everything goes in there to support that. 5 years later, they're only at 500 kilowatts or something like that, or a megawatt as such. So meanwhile, all the cooling systems are still there. They're still, in a lot of cases, they're still operating as such. So just awareness of what's going on, what can be done to improve operations in data centers. One of the things that we talk about a lot with our customers is the total life cycle. When you're looking at buying servers, when you're looking at buying equipment, look at the total life cycle cost of that. Don't let procurement drive you down the road of cheapest product. What's it cost you from an energy point of view? What's it cost you from a capital point of view for that equipment? What's it going to cost you to recycle that equipment as well too? So let's look at it from a total life cycle perspective and put that into play in there. And just as I mentioned earlier, I think eventually immersion cooling is going to be here. It's coming slowly, but it's quite a adoption process for most companies. But I think there's a lot of benefits in immersion cooling. When I look at the part of the work that we did for this calculator was to look at the various types of cooling systems that are out there, and when you do the analysis from an energy point of view of immersion cooling relative to anything else that's out there right now, I mean, it's far beyond being more efficient. It's a factor of, I'm not sure a factor of a lot of more efficient from an energy point of view, but it's getting over that adoption barrier for people to do that. So. So I think that's, from my point of view, we work in the legacy world. It's getting people to adopt more and more of what's available, what's out there today.
I think for me, I think again, I'd like to go back to adopting a holistic and integrated approach. And at the same time, actually taking care of the details at the different levels, right? From raised floor to rack to row to room level, right? So I think earlier on, Mr. Murphy has actually mentioned, right, for example, the use of blanket panels and whatnot, right, to sort of, for example, avoid cold air bypass, hot air recirculation. So I think all these details has to be taken care of, and together with a holistic and integrated approach, I think that would actually ensure that we move towards really an optimal design as well as optimal operation of our data center, achieving the kind of carbon footprint reduction that we hope to realize. Yeah. So I think that's really the approach, a holistic and integrated approach, and at the same time taking care of the details at different levels.
Gotcha. All right, we all have to get better at what we do. Dig deeper, look at things overall. I like it.
Yeah.
Well, I want to thank you both, Professor Lee, Mr. Murphy. Thanks for being on this panel, and I think we're all willing to answer any audience questions that comes out of this. So, have a great rest of your day.
Okay,
Great. Thanks, Kevin.
Thank
you,
you.
Professor.
Thank
Bye-bye.
you, and Kevin. Bye.